So this has just me as expiring dates or something.
Yeah, next week.
So is it so people, ask us on paper? I mean, like,
Don't you dare.
so it's impossible because I got so many answers wrong with this. I didn't put it in for this video.
Don't worry about the mark.
Right?
Don't worry about the mark. Just make sure that you do it, and make sure that what you're doing is right. If you're doubtful of what you're actually putting in there, then obviously reach out to your friend, and then just verify each other's answers to be correct. Okay. It's more about the practice than anything. Yes, yes, you'll still get your 10%. Yes, makes sense. The mark doesn't matter at all. Okay. Yeah, that's how it used to be. I don't know why they changed it. So, but the only way you won't get 10% is if I only have, remember, I only need 4. If I don't have 4, then obviously I have, and maybe you would have done maybe 2, then obviously you get 50% of the 10%. If I get 3, then you get 75. Go look at my first lecture, because we had that discussion. All right, I don't want to steal away from this lecture time. Test 1, we said was how much? 25%. Test 2, 30%. Exam, 35%. Exam is your third written. Yeah, 2 tests, 1 exam. Okay, right, but that's for accounting. Okay, right. Awesome. Okay, so with factorizing, I really think maybe, or simplifying, what I would suggest is that if we can actually just look at a few YouTube channels, YouTube videos, sorry, because I don't know how best to explain it. It's one of those things that you kind of just have to look and see, okay, how can we get this thing in brackets? That's the primary goal, okay? And now let's just quickly look at the things we did yesterday. I think that's the only way we can really, yeah. Let's explain it. Okay, so there we have B, all right? Oh, gosh. All right, and there again, I know they didn't write this out properly. So let me get yellow. This B was supposed to be 3x, and this is supposed to be 3y. Just double checking your manual that I'm doing this right, because I'm not on that page. Then minus 12x, all right? I think this is to the power 2, and then this is y to the power 4. Thank you. And then plus 6xy. Is that right? Okay, cool. Right. So the first thing that you want to do when simplifying it, I'm just going to use the term I'm more comfortable with, is you want to look for a number that's going to get into all of these numbers. Okay? And there we can see that all of these numbers are divisible by 3. Okay? So then that's exactly what we then use. Okay, so we use 3 because it's a common common multiple, common factor. We can work with that. Okay, so 3. Then we say, okay, in terms of the letters, we know that there's an x and a y involved in all of them. Okay, all right. So we then can put down xy. Okay. Then we say, okay, no problem. Then now what must happen over here? We then can now go one by one and start wherever we're really comfortable. Okay, we can say, okay, cool. So this is 3x and then 3y, right? But I don't think we started here. I think we actually started over here for some reason. So let's do that so that we can follow the same answer. So then we say, okay, 3 into 12. Then, yeah. Yeah. This, what? Yeah, this is 17, right? Not the answer, right? Okay.
What page is it for?
Oh, this is 3B. Ah, I see. This is supposed to be to the power. This is supposed to be 3x cubed. That's why. Not 3y. Okay. All right. Now, okay. Now remember, when something is to the power of, it's either going to result in us having to subtract or add. Okay. So we've got this as our common factor. All right. Then we're saying, okay, what times 3xy will then give us 3x cubed, all right, with a y. Okay. Then we say, okay, cool. We already have the 3xy, but then we obviously need to get this x to be cubed if we're to expand, right? So then we say, okay, we know that x to the power 2, right, will then plus x to the power 1, because this is to the power 1, and this y is to the power 1. But obviously, since it's just to the power 1, we don't actually put it out there. Does that make sense? So if we say 3x, all right, to the power 1 plus y to the power 1 times x squared, we would then get 3x cubed y. Does that make sense? Okay. All right. So I hope as I'm explaining this, you're figuring out how best you are going to approach it in your mind. Because like I said, I know it's not the easiest one to actually explain, but I hope you're getting it as we go. All right. Then here we're saying with 12x to the power 2, and then y to the power 4, we know that 3 gets into 12 4 times. Okay, so we can put that down. And then we know that x to the power 1 plus x to the power 1 will then give us x to the power 2. Okay, so then we just put down 1x next to the 4. Does that make sense? Okay, then we have y to the power 4. Okay, so we already have y to the power 1 over here. We then obviously need to add 3 in order to get to y to the power 4. So we then simply say y to the power 3, and then we have our second term there. Make sense? Everybody happy? Cool. Then the final one, a little bit easier, is 6 times or 6xy. All right. So we already know that 3 is going to get into 6 2 times. So we put down the 2. Then we see, okay, here we have x to the power 1 and y to the power 1. Okay. But we already have xy over here to the power 1 and y to the power 1. So we don't actually need to have those symbols, or should I say letters as well, okay? Because we know that 2 times 3xy will then give us 6xy if we were to expand. Does that make sense? So that's how I approach it. Does it make sense? Have I helped you in any way? A little bit. it makes more sense now. Yeah, sometimes it really is just about having these sessions face to face. You can never really completely replace face to face. But yeah, maths is one of those, because the way we approach things, how we see logic is different. So it's really just about saying, okay, what then makes sense for you? How would you break this thing down? Okay, I show your hand. Is it possible? Really? It would probably take longer, because then you would have to look for more common factors. Make sense? So yeah, it may be possible. I wouldn't say it's not. Okay, but then you would have to look for more common factors. Um, and you may find yourself not using whole factors as well. I don't know. I'm just thinking out loud. Yeah. All right. Cool. Right. But once again, I think the challenge here is that you need to be patient with yourself, not to rush to say, "Ish, I just want to arrive at the answer." You need to start by saying, "What is the what number gets into all of these?" And you sometimes might find yourself in a position that you can't actually simplify. That is a reality. Okay, and we'll be testing when you know, when you can, and when you can't. Okay, but this is one of those that it's just really about practice. I think you leave it as is. That means that it's already in its simplest form. Okay, unless you can say, okay, maybe we can divide by 2 the whole thing. But then really, if you can divide by 2, that means that you can then have a factor. Does that make sense? So, but then you might find that, let's say for instance, if we had a 5, I'm just going to erase this first one and say we had a 5 over there, then it would be a problem. Okay. In fact, I think even there we might still be able to factorize, because what it then means is that this 5, we would just have to have, our factorizing would be xy. We wouldn't have a number. Does that make sense? And then we would have 5 over there. So there's usually a way, but if ever you find yourself in a situation where you really cannot, then you would leave it as is. All right? And there are some situations where you really can't actually simplify. Awesome stuff. Right. Then, Mr. Oliver, it is now your time to shine, sir. Come and do the simultaneous thing. We can do it on the board, so that um, we obviously have it on the recording. We did 9. Did anyone do 8? Come through. The people have spoken. Come, you get to use this nice little pen. Yeah, do 9 since you did that. Yeah, that's simultaneous. Yeah, you can do 9. You could even bring your notes if you want to. Okay, but if you want to, if you calculate it, okay. Well, that not. Are you in it? Yeah. This is weird, sir. He's doing such a great job. Isn't he neater than me? So much neater. Look at that. Please? um, okay. So what he's basically doing, so you just press this button. That's the first one. And then press it, and then, yeah. All right. Continue doing what I do. I'll try and make sense of what he's doing. So if you look at what he's doing, you can see that he's just taken those two equations, all right, and then he's grouped x the x's together and he's grouped the y's together, and then he's also basically just what's it? He put the like terms together. Am I right?
Yeah. And then you substitute this x into this one. So it'll be 4 in brackets 18. Yeah. And then if someone doesn't mind doing that,
all right. You want to pick on who to do that? Maybe?
yeah, TK. So 3 over 18 will be 6. So 6 times 4 is 24. 4 over 3 is what's 4 times 4 over 3?
Take your time, don't worry.
Okay. Can I get the anyone have a scientific calculator? That's how you get the fraction version. Yeah? 16 over 3. And then then you rotate that.
This yeah. Really good.
Then you add the two y's together and you bring that side so then it's I'm done.
You done? I will be very honest. I'm not sure. Okay. Yes. The question is. Yeah. So you have to put basically. So okay, let's do this thing together now. Oh, sorry. It's page 66. It's still coming around there somewhere. Okay. So I see what you did over here. We started with a 9. Okay. Firstly, let me fix the way I've done this question. Okay. We've got our simultaneous equation there, and then we have our second simultaneous equation over there. Okay. Right. So, sir, thank you. Thank you very much for your effort. I can't make sense of what but again, thank you for coming up and doing your thing. All right, so let's try this thing together again, and let's work through it together, and let's see how far we get. Right. So first things first, you want to organize your equation All right, so here fortunately, let me zoom in a bit. Here fortunately you can see the x's are already together, the y's are already together, and the full numbers are already together. So I think the easiest way to then go about this is to then substitute. Let's first solve for 1. Okay, so here you can either solve for x or you can solve for y, right? So let's solve for x first. Okay, and so what we're going to do here is we're going to then say y is equals to 0. Okay, so for the first one we say 3x, all right, plus 0 is equals to 18. Okay, and here we're going to say 4x uh, plus 0 is equals to 23. Okay, we've done that. Now what do we do next? How do we do that? I remember I substituted y with 0 so that I can solve for x. Um, okay. So, I'm sorry. What we needed to do actually first is to first multiply by 4. So let's quickly do that. Sorry. The first equation we are supposed to multiply by 4, and the second one by 3. Okay, so let me actually just follow the instructions of the manual here. So this, because can you see this is 3x, okay, and this is 4x. All right, so we want to get x to the same amount. So here we're going to times it by 4, and here we're going to times this by 3. Okay, so for here we're going to have 12x plus 16y is equals to 4 times 18. What do we get? We get 72. Okay, and then 3 times 23, what do we get? 69. And 3 times 5, we get 15y plus 12x. Okay, can you now see that x's equal to each other there? Okay, that's where they're now saying we have equation. Remember, this was our first equation, our second equation, and now we're having third equation and fourth equation. Okay, then the next step that we then need to the next thing that we then need to do is to then substitute. Okay, is to then substitute. We can say y is equals to 0. Okay. Okay. We can say y is equal to 0. There I see they said y is equals to 3. Okay. But here we can say y is equal to 0. It's fine. You can pick any random number. Huh? Which equation? The main one. Okay. These are the main equations. Yeah? We're on A, yes. Okay. Cool. Happiness. Can you see it? Sorry, you raised your hand. You want to say something? Okay. Mm-hmm. So basically, this top one from this one. So did they made x 0 then, right? Okay, so they made y then the subject basically. Okay, so this becomes 0. So this minus this minus that, we have y is equals to 3. Okay, right. So in other words, yes, y is then equals to 3, and then they use substitution to then move forward. Okay, I should have actually gone through this. My bad. Okay, so now you can pick any equation to find out what x is equal to. Okay, so let's just pick the second one because we have there 15. So we're going to say 15 times 3 is equals to 69 plus 12x. Okay, right. Then what is 15 times 3? That's going to give you 45, right? Is equal to 69 plus 12x. Okay, then what you do is that you shift it to the other side. Okay, so 69 minus 45, that's going to give you 24. 24 is equals to 12x. Divide 12x by 12 and 24 by 12, and you get x is equals to 2. Okay, all right. Now that you have what x is equals to, okay, you can now actually then find out what y is actually equals to. Okay, and we do that by doing substitution. Okay, so we then say we can pick any one of the formulas. Okay, I think yes. Oh, sorry. Yeah, we're done. I'm looking at the B section, and I'm thinking we still need to go on. Okay. Yeah, no, it is not today. All right. So our x is equals to 2, and our y is equals to 3. Okay. So I think let's now recap on our process. The first we need to do is we need to times our initial equations, all right, so that we can get the same x. Why do we want the same x? So that we can take out x. So that x then will become 0 when we minus equation 3 from equation 4. Does that make sense? Okay. We could have actually done this thing the other way around, where we actually decided to say, you know what, let's eliminate y. Okay. What would have happened is we would have times the first equation by 5, okay, so that we get a 20y first equation, and then the second equation we would have times by 4, so that our y would then be equal to 20, okay, and then obviously we would then eliminate our y, and then we would then solve for x, okay. Then when we have x, we can then substitute x, and then calculate what y is then equal to. Okay, so let's do that with b. Okay, so we have b over there. Now where shall we calculate these things? Okay, no, it's fine. We'll just scroll down. We only raise this. I'm gonna change colors now. All right. Let me just get this. All right. So our first, this is our initial. Sorry, someone saying something? This is our initial equations. 10x minus 6y is equals to 26. Okay, and then we have 7x plus 3y is equals to 47. Okay, so now let's do this thing with y. I want us to use the opposite of what they use. What did they use here? They eliminated y. Okay, All right. So then let's eliminate x. Okay. Let's eliminate x. I just want to do, or do you guys want to do y? Since we did x the first time, up to you guys. Because I want to show you that we can get to the same answer either way. What are we going to do? Eliminate x or y? Okay. All right then. Let's eliminate y. It's going to be easier doing it with y because y is smaller. Okay. So the first equation we go times 3. Okay. And then the second we're going to say times 6. Why are we doing that? So that we can eliminate, right? So that our y will be equal to each other. Does that make sense? So when we subtract the first equation from the second, we'll get a 0y. Okay? All right. So 26 times 3, what do we get? Okay? So we have 78 is equals to 3 times 6 is 18y. And then 3 times 10 is going to be 30x. Okay? Minus over there. Then 6 times 40 is obviously going to be 18y. 282, okay? Then 6 times 7, 42. Okay, cool. All right. Okay. Right. So can you see something here? We have a situation where 78, we said 3 times 26. Okay. Can you see something here? We have a situation, if we say our first equation minus our second equation, are we going to manage to eliminate y? But look at your first equation. Your first equation is a negative 18, and then your second equation is a positive 18. So will we manage to eliminate? Yes, so on minus 18, what do you get? Exactly. So what must we do? No, we can still eliminate y. We should just add. I think we should just add. How come these guys times by 2? Exactly. So this will be 0. All right, and this will be what? So we added. I'm just going to put this on the side so that you remember we added, we didn't subtract. Because the whole purpose of why we're doing this is to eliminate one of the variables, either x or y. This is going to be 360. Okay, and then this is going to be 72x. All right, plus 0. Okay, so in other words, we can now erase this. X is equals to 72x is equals to 360. So we divide by 72 over here. And what is then x equal to? So x is equals to 5. Okay, so now we have our x. We're halfway home. Okay? Right. Then what must happen? What must we do now? We have to substitute x. Yes, wherever we have x so that we can get y. Okay? So we can pick any of the first two there. I'd advise any of the first two because those are smaller than the second two that we did. Okay, so let's pick which one do you want to pick, 1 or 2? Okay, 10x. Okay, so that's 10 times 5. So that's 15. All right, plus, is it plus or minus? Minus what? Is it 30? Plus, minus 6y is equals to 26. Remember, we're doing, yes, we're doing this first one. Isn't you said 10x? Yes, and we know x is equal to 5, right? So that's how we're getting there, 50, and then minus 6y, okay? And then so let's throw this over to this side to make our lives easier. So 50 minus 26, what do we get? Yes, we're substituting x so that we can solve for y. Are you with us? We're still fine. Okay. So then we say divided by 6, we're going to get 4 over here. And here we're going to divide by 6 as well. What you do on the left, here, you do on the right. Okay, and then y is equals to 4. Is everybody happy? Okay, cool. So for me, I would solve all my equations via this method. All my simultaneous equations, I just do it via this method. Okay. You can do it graphically, which is what is happening in 8. Okay, but I find it so much easier to just do it via um, substitution and elimination. Okay. Everybody happy? Okay, cool. Yeah, awesome stuff. Okay. Right, right, cool. Um, so then what I want us to do now is I'd like us to just go through the theory for Unit 3. It's a very easy unit. I think it's really just about graphs and tables, okay? But I think you really begin to understand and master this when you actually go on to do your graphs and your tables. And then what I want to ask you guys to quickly do, and this is for whenever next to see, because I think they could very well just ask you to do this simultaneous solve for x and y graphically, right? But I don't want us to spend too much time on it like we did with the elimination. So even I'm going to do it. Alright, make sure we are on point and you guys are there. But you can just do number 8 in your own free time before we come to class together. Alright. So yes, unit 3 is using tables and graphs. Okay. Now the science of statistics, alright, is defined as a set of mathematically based tools and techniques to transform raw data into a few summary measures that represent useful, usable information to support effective decision making. Okay, right. I heard somebody go, yo, when I said the science of statistics. I really like what they've broken down here because what they highlight is that there's really nothing too deep about this stuff. And I will admit that even I was like, statistics, okay, it's about to get real. All right. But really, all that it is putting raw data together so that we can look at it graphically, so that we can then obviously, graphically or via table and charts, so that we can then obviously look at the information and then obviously interpret the data so that we can then make decisions. Okay? That's all that it is. Such data may be qualitative or quantitative in nature. All right. We will primarily focus upon quantitative data in this module. Okay. So qualitative is basically words. All right. Whereas quantitative is actually numbers. Okay. All right. So we are going to be focusing on data that is numbers orientated. Okay. Now you get two types of quantitative data. Okay. You get discrete and you get continuous. With discrete, right, you get an exact whole number when it comes to discrete. All right. Whereas with continuous, it can literally be, it's not an exact number. For instance, with discrete, if I say to you how many cars are in the parking, it's an exact number. Okay. Whereas if we're to measure temperature, it could literally be any number. All right. Today it could be this number. Tomorrow it could be that number. It could it could be potentially anything. Okay. All right. Let's go down. Okay. Then they go on to distinguish between interval scale and ratio scale data. Okay. Interval scale data is where if the relevant quantitative random variable can generate negative numerical values. Okay. So that's the key distinguishing factor. If the data can be negative in nature, all right, the numbers can be negative, all right. We say that it has non-absolute zero, okay, right? It has non-absolute zero. It is, if this is the case, then we are dealing with interval scale data, okay. And do they give an example? They don't give an example. Okay. But again, temperature I think is a good example. Oh, on the next slide they do give temperature as an example because you can have negative degrees Celsius and you can have positive degrees Celsius. So can you see that is then interval scale data, okay? Whereas on the other hand, when we talk about ratio scale data, all right, it cannot generate negative values. So that would be easier to express. All right. So if we're looking at distance, or yes, you want to take a break? Oh, okay. Yeah, you can take a break. Um, well, we're on slide 7, and there's like 21. You're not going to go in detail because it's really about drugs and stuff, but it's okay. Take a break. Yes,